start the recording. So we'll have a look at number 6 again. Can you see okay? Yeah. Right, 6. Do you have it? You have the question, don't you, here? Okay, so, well, first things first, let's open up the program. What's that?
I went to the chemistry program.
Okay. Mass. Yes, this is mass in grams. And this is the lower. This is page 9. Yeah. Lower, upper. 35, 45, 50, 55, 60, 70. And then upper, 45, 50, 55, 60, 70, 85. And then the frequency, 36, 40, 52, 42, 50, and 30. Okay. So that's what I have so far. Is that okay? It's just, I'm just putting this table on the screen as well. Lower, upper, and frequency. So the first thing I want you to calculate is the mean. So the mean, to calculate that, you have to use this formula. The mean is the sum of the frequencies multiply the data all over the total frequency. So what I'm going to need to work out is the total frequency. Total frequency. So if I just add all my frequencies together, I get 250. Okay, so let's work out the mean. So the formula is, I haven't worked out the midpoint yet. So I need to work out the x, which will just be the middle of the lower and the upper. Okay, so the mean is x times f plus 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 x times f divided by the total frequency, which is 250. So when you put that in on your calculator, you'll get mean is 56.24. And that answers the first part. So is that first part okay for you?
Yes.
Yeah? Now the next part is the frequency densities. So the densities, or the height of the histogram bars, is the frequency divided by the width. So I need to work out the width next. Is there someone at the door? Did you find them? Yeah. Okay. Now, we have to work out the width. So that is the upper minus the lower. So they're all the class widths there. And now we can work out the height, which is the frequency divided by the width. Okay, can I draw the histogram now?
Yeah.
Or you need a minute? I'll let you copy them down because I need you to read them back to me. Got it, okay. So can you give me, Grace, give me all these numbers here so I can draw my histogram. Just a second now. Alright, so what does it start with?
35.
Okay, so let's try and draw this neat. So this is 35, and it goes all the way up to...
70.
Okay. Whoops, 55, 60, 65, 70, 75, 80. Now, of course, in the exam, you'll do this neatly on graph paper. This is the mass in grams. And then here is the density, which is the frequency per gram. What's the biggest height? H.
H is 10.4.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up there. Okay, so what's the first height? Oh, what's the first bar? 35 to 40, is it? Yeah. Yeah. I can see it's 35 to 45, and its height is 3.6. Okay. And what about the next bar? And its height?
Its height is 8.
45 to 50?
Yes.
It's smaller, is it?
Yes.
Okay, and the next one?
The next one is 50 to 55.
And its height?
10.4.
Okay, so that's the big one, alright, 50 to 55, and the next?
55 to 60.
Yeah.
And its height is 8.4.
Okay.
The next one 60 to 70.
Uh-huh.
Its height is 5.
5. And then the last one, is it?
70 to 85.
Yeah, and its height?
2.
Exactly 2, okay. So this one here has an area of 36. This one has an area as well. Right, this one here, 36, 40, 52, 42, 50, and 30. So if you have something like that put on graph paper, then that would be 5 out of 5. I should, of course, mark my numbers off the side here. They're just the frequencies on the table. Just these numbers here. I don't need to do that, I just did. Okay. Can I do the next part?
Yes.
Yes. So they said the heaviest 50 eggs are classified as large. So, how many eggs do I have between 70 and 85?
Yes,
30. And how many between 60 and 85? 80. So I need to find somewhere where it's the top 50 eggs. Because if I start here to here is 30 eggs, but here to here is 80 eggs. So it's going to be somewhere roughly around about here, where it'll make 50. So can you see the shape I'm making? This piece here has 30 in it, yeah? So how much should be in this piece here if I want 50? In this rectangle piece here? Should be 20. And how do you get the number inside? It's the area. So if this is x, what's the height here? The height is, what was the height here for this second last one? Was it 4 point something? It was 5, was it? Okay. So its height is 5. And what do I want in the inside? 20. So what must the x be if I want 20 inside here? 5 by what makes 20? 4. So this piece here is 4 big. So if it ends at 70, it must start at 66 to make it 4 big. So the answer is 66 grams.
Mr. Stephen,
Yeah.
but the question says we have the S50X.
Yeah.
Does it mean the bar says right above 15?
Well, the heaviest 50 eggs means the top 50. So that bar has 50 in it. That's what the 50 heaviest eggs. You're just saying that there's 50 eggs of 60 to 70 grams.
Yeah.
But there are 30 eggs heavier than that. So I know the answer must be somewhere between 60 and 70.
Oh, that's, sorry.
Yeah. These are like
This is the mass.
Yeah. Yeah.
And this is the weight.
How many of them you have? Yeah.
And here, this is the height.
Yeah.
So, actually, we are looking at the last bar because they are the heaviest.
Yeah, that's it. They're the heaviest ones.
So, the last 50.
Yep.
Yeah.
Yeah. So you're good with that?
Yeah.
Can we go on to the B part then, yeah? Yeah? I can scroll down? Okay. So the B part is they say, they give you, I'll go back to my Excel program, new tab, they give you 11 numbers. So here's our data. -4, -3, well, I'm going to start with biggest to smallest. 17, 12, 11, 10, 8, 3, 2, 0, -1, -3, -4. Okay. And they want the mean. How do you calculate the mean average? Sum and divide by how many you have. So let me write down how many I have here. I have, oops. Is it? I think I knocked something out here. Oops, I did. 11. That's how many I have. Okay, so the mean, you're right, you have to add them all up and then divide by how many you have. So the mean is 5. That's okay, isn't it? That's straightforward. Now the next thing we'll need to do is get the mean squared. So that would be 5 squared, so that's 25. Okay. Now, next we need to work out the x squared so we can get the standard deviation. Whoops. Come on. There we go. So the x squared, that would be the same deal again, sum of all these numbers divided by how many you have. So that's it there. And finally, do you remember the formula for standard deviation?
Yeah.
It's square root this number minus this number here. So I'll just write it down here for you. The mean is the sum of the data divided by how many you have, and the standard deviation is square root this minus this one. So let's see what I get here. 6.62. So I get 5 and 6.62. Okay. Lastly is the median and the interquartile range. Okay. Oops. So if we look here, here's the first one, here's the second one, third, fourth, fifth, sixth, 7, 8, 9, 10, 11. So if I have 11 numbers, which one is the middle one? It's the sixth one. So the median is 3 here. And the interquartile range is the upper quartile minus the lower quartile. So here is my lowers. 1, 2, 3, 4, 5. Yeah, so the lower quarter, the upper quarter is 10, I think. Let me check that again, sorry. No, it's 11. The upper is 11, and the lower is at minus 1.
Sorry, what?
Yeah, so what you do is, you split them into 2 halves. So maybe if I put a new line here would help. You see how I've split the data into 2 halves now? So the median is there at number 6.
Yes.
And this is the upper half. What's the middle of these 5 numbers here? 11. Yeah. And what's the middle of, yeah, what's the middle of these 5 numbers? Minus 1. So that's the upper and the lower, by using the method of not including the median. So 11 minus 1, which is 12.
The upper quartile is usually
The bigger one. Yeah. 3/4 of the way from the bottom, or a quarter from the top. Do you remember I said that, roughly speaking, the interquartile range should equal twice the standard deviation, roughly? Do you think that's true here?
Yeah.
It is, isn't it? So it means we probably did everything fine. Okay, that's number 6. Now, I did this a little bit quicker than what you could do in the exam, because you're supposed to use graph paper and a calculator, but I don't think it's too difficult. Okay, yes.
You must arrange the data for
Yes.
get the smallest.
How small is the biggest? It doesn't matter.
Doesn't matter.
No, but they already have it in order for us, so that's nice. Just make sure the upper quartile is the bigger one and the lower quartile is the smaller one. Okay.